Welcome everyone. It is 3 p.m. and it's time for the Server Room Show. This is episode 76. Today I will talk about, probably today and maybe the next couple of episodes, I'm gonna talk about a collection of operating systems. None of these are Unix, and the interesting thing between them that they are closely influenced one another. These are Oberon, Plan 9, and Inferno. And yes, it's true that none of these operating systems I want to talk about in this episode, and probably the next one, and maybe even one more. Maybe again a 3-part episode. We will see how much material I have here prepared. None of them are what we would call Unix or Linux-like operating systems. They might have similarities and or resemblance to Unix-like systems. Plan 9 was made in Bell Labs, where Unix was born, and was indeed was building on the Unix concepts, but there is a clear connection between these systems, like I mentioned. They are not usual in any way. Seriously, they are very non-usual, to be honest, and like I mentioned, they were influenced by one another. Started with Oberon, and then Plan 9 and Inferno. Oberon is the first one I want to talk about. As always, the show notes is great to accompany the podcast, the audio only version. The Oberon system is a modular single-user, single-process multitasking operating system written in the programming language Oberon. It was originally developed in the late 1980s at ETH Zurich. The Oberon system has an unconventional visual text user interface instead of a conventional command line interface or graphical user interface. This text user interface was very innovative in its time, and influenced the design of the Acme text editor for the Plan 9 from Bell Labs operating system. The latest version of the Oberon system, Project Oberon 2013, is still maintained by Niklaus Wirth and several collaborators, but older ETH versions of the system have been orphaned. The system also evolved into the multiprocess symmetric multiprocessing capable A2, formerly called Active Object System, or AOS. Then it was called Blue Bottle, with a zooming user interface. The Oberon operating system was originally developed as part of the NS32/032 based Ceres workstation project. It was written almost entirely, and since the 2013 version is described entirely in the Oberon programming language. The Ceres workstation was a workstation computer built by Niklaus Wirth's group at ETH Zurich in 1987. The central processing unit is a National Semiconductor NS32000, and the operating system named the Oberon System is written fully in the object-oriented programming language Oberon, as I said it earlier. It is an early example of an object-oriented operating system using garbage collection on the system level and document-centered approach for the user interface, as envisaged later with OpenDoc. Ceres was a follow-up project to the Lilith workstation based on AMD bit slicing technology and the programming language modular 2. The basic system was designed and implemented by Niklaus Wirth and Jürg Gutknecht, and its design and implementation is fully documented in their book Project Oberon. The user interface and the programmer's reference is found in Martin Reiser's book The Oberon System. It was later extended and ported to other hardware by a team at ETH Zurich, and there was recognition in popular magazines. Wirth and Gutnacht, although being active computer science professors, refer to themselves as part-time programmers in the book Project Oberon. In late 2013, a few months before his 80th birthday, Wirth published a second edition of Project Oberon. It details implementing the Oberon system using a reduced instruction set computer CPU of his own design, realized on Silingsfield programmable gate array FPGA board. It was presented at the symposium organized for his 80th birthday at ETH Zurich. In the meantime, several emulators for this version were implemented. According to Joseph Tempel, former member of the developer group at Swiss Federal Institute of Technology in Zurich, and later member of the Institute for System Software of Johannes Kepler University Linz, where one forked version 4 was maintained. The genealogy of the different versions of the Oberon systems could be described as below. The start of the Oberon project was in 1985. Then version 1 came along in 1987, marked for internal use at ETH Zurich. Simple text editing facilities only. In 1991, version 2, extensible text model and a special editor named Write, supporting these extensions. In 1991, System 3 kernel extensions supporting persistent objects and object libraries, supporting object embedding and object linking. Gadgets script, which is or was a text editor, and Illustrate, which is or was a graphic editor. In 1992, publication of the so-called Oberon trilogy, which consisted of Project Oberon, the Oberon system, and programming in Oberon. In 1992, version 4, functions of Write integrated into standard text editor. Release 1.4 for desktops. Then in 1993, release 1.5 generic document model. In 1994, version 4, Hans-Peter Messenberg pointed at version 4 development moves here, and this pointer is wrong here in this text. Let me see. In 2000, ETH Oberon System 3 is renamed ETH Oberon, and 2002, when AOS Active Object System, also known as Active Oberon System, which was later renamed to Blue Bottle, then A2, comes to the surface. And 2013, we could call it version 5 of the re-implementation of the original Oberon system in FPGA, the Oberon 2013. Oberon has a text user interface, which is very different from a terminal user interface. It combines the point and click convenience of a graphical user interface with the linguistic strength of a command line interface, and is closely tied to the naming conventions of the Oberon language. Text appearing almost anywhere on a screen can be edited and used as command input. Commands are activated by a middle mouse click on a text fragment of the form module.command, optionally followed by parameters which are terminated by a special symbol. A command is defined by any procedure which is exported and has an empty argument list. The parameters to the command must be defined before executing the middle click, and must be explicitly scanned and retrieved by the procedure. No checks or questions occur during command execution. This is sometimes called a non-modal user interface. Nothing like a command prompt is needed. Although very different from a command line, the text user interface is very efficient and powerful. A steep ascent in the early learning curve makes it a bit difficult at first, and no questions are asked. This is a deliberate design decision which needs getting used to. Most editors ask the user when closing a modified text. This is not the case in the Oberon system. The use of the text user interface and the programming interface is fully documented in Martin Reiser's book, The Oberon System. A short introduction to the user interface can be found on Niklaus Wirth's homepage. The later versions of System Oberon, version 5, sometimes also named Linz Oberon, and Oberon System 3 or S3, sometimes also named ETH Oberon or Spirit of Oberon, enhanced the basic interface with different but incompatible implementations for buttons, drop-down menus, and other active elements. Version 4 used for that purpose a dedicated control character embedded in normal text, in contrast to System 3, which extended the kernel by introducing persistent objects. Both extensions include a large set of user interface elements. Mastering the Oberon user interface, both the purely textual and the so-called gadgets system under S3 is non-trivial, and thus after successfully installing Oberon System 3, it is recommended to study Andre Fischer's Oberon System 3 tutorial. An expanded version of this tutorial was published as a book, which it is out of print as of now. The whole book is available in electronic form under one user license in every installed version of System 3, being it Windows, Linux, or native, also with the Gadgets Toolkit of OLR. More information on how to get your own copy of the Oberon companion may be found in the Getting Started section of the Oberon wiki book. Similar user interfaces have yet to appear in more commonplace operating systems. Rob Pike's Acme system for Plan 9 from Bell Labs was strongly inspired by the Oberon text user interface. Whether the worksheet interface of the Macintosh Programmers Workshop influenced Oberon's text user interface or vice versa is difficult to decide. The Oberon system was based on Wirth's prior computer design, the Lilith, and both the Apple Macintosh and its precursor Lisa and the Oberon system on Ceres and its precursor Lilith have the same roots. They were all inspired by the Alto developed at Xerox PARC. Versions and availability. Version 1 was the first usable version sometime before the Oberon trilogy was published. A major change in the text model, together with the editor named Wright, yielded version 2. As foreshadowed in the table in the previous section, where I already tried to read it out loud, there was a major fork in the early 1990s. Version 4 versus System 3. The group around Jürg Gutknecht introduced persistent objects and object libraries, thereby extending the kernel. The group around Hans-Peter Mussenberg realized similar features by introducing active elements mapped to a special character, thereby extending fonts without changing the kernel. System 3 was sometimes also named Spirit of Oberon and later renamed ETH Oberon, whereas version 4 was sometimes also named Linz Oberon. As of 2017, the Oberon OS is available for several hardware computing platforms. generally in no-cost versions and from several sources, which is quite confusing. The Oberon OS is typically extremely compact, even with an Oberon compiler, sorted utilities, including a web browser, TCP/IP networking, and a graphical user interface. The full package can be compressed to one 3.5-inch floppy disk. There are versions which emulated the Oberon OS on another operating system, and versions which run on bare hardware. The latter ones are named native Oberon. There are native versions for the Ceres, Intel i32 and ARM platforms. In 2013, Niklaus Wirth adapted the basic system as described in Project Oberon to a current FPGA design. According to the preface of the 2013 edition, the whole system compiles in less than 10 seconds on a Spartan 3 board. This version is sometimes also named version 5, despite it being much more similar functionally to the original version 1 running on the Ceres than any of the later versions. A version of the Oberon System 3, which was integrated in the Microsoft Windows operating system, was named Plugin Oberon. Plugin Oberon supported the binary format named Oberon Module Interchange, or SLIM binaries, which allowed portable object code between Intel x86, Motorola 68K, and PowerPC architectures. SLIM binaries were invented by Michael Franz in the early 1990s. They were motivated and opposed to the FAT binaries invented by Apple during the transition from 68K to PowerPC architectures. OMI provided portable code based on a compressed version of the abstract syntax tree. The approach of compressed abstract syntax tree is revived for Graal, VM, and Truffle. The version named Oberon version 4 is closer to the original operating system developed by Wirth and Gutknecht. It was originally developed at ETH Zurich, but when HP Mossenbeck went to Institute für System Software at Johannes Kepler University in Linz, the development of version 4 moved also. Thus version 4 is sometimes also called Linz Oberon in contrast to ETH Oberon. The most recent version of version 4 and extensions are available at Johannes Kepler University in Linz. Oberon version 4 appears to be orphaned. There are almost no changes since the year 2000. Another repository of version 4 is Claudia Nieder's Oberon version 4, which also shows a difference between the different version 4 implementations. Since 2013, this page moved to or is mirrored at SourceForge. Version 4 is closer to what would now be called an integrated development environment than an operating system of its own. There were many extensions written for version 4 which are still available from the FTP server of SSW at JKU, which is Johannes Kepler University of Linz. Some documentation can be found on their web pages. More information is normally included in the packages, and it is given in Oberon's special rich text format. Around 2010, the computer science department at ETH Zurich began exploring active objects and concurrency for operating systems, and has released an early version of a new language, Active Oberon, and a new operating system for it, first named Active Object System, AOS for short, in 2002. Then, due to trademark issues, renamed it to Blue Bottle in 2005. Then renamed it to A2 in 2008. It is available from ETH Zurich with most source via the internet. Native versions of A2 run on bare hardware and are currently possible for Intel i32 and x86 64 single and multiprocessor systems, and for the strong ARM CPU family. Versions for other operating systems are available, like Windows, Unix, Linux, Mac OS. There are also more information about A2 is on Russian Wikipedia pages about A2. As a part of an industrial research project, the Native Systems Group of ETH Zurich has developed an application-specific operating system named Styla OS, which is based on the latest version, Oberon OS. It is intended for uses such as real-time analytics, high-performance automated trading systems, main memory-based enterprise resource planning, ERP, and so on. Native Oberon is an Oberon system that runs on bare hardware. PC native Oberon is a version that runs on i32, x86-32 PC hardware. There has never been a V4 native Oberon, so all information implicitly assumes that we are talking about the system 3. Native Oberon has small hardware requirements, 133 MHz Pentium, 100 MB space on a hard disk, VESA 2 compatible graphics card with a resolution of at least 1024 by 768 pixels, and an optional network card. It mentions the 3Com network card. The basic system runs from one HD floppy disk, and more software can be installed through a network. The full installation includes the gadget's graphical user interface. It is written fully in the language Oberon. A version named the Linux native Oberon uses Linux as a hardware abstraction layer. Its goal is to be as compatible as possible to PC native Oberon. Other versions of the Oberon system without native in the name had partly modified interfaces of low-level modules. In 2015, Peter Matthias revitalized Linux native Oberon under the name Oberon Linux Revival as a multi-platform distribution running seamlessly on Intel x86, ARM, MIPS, and RISC-V. It runs well on the Raspberry Pi and on the low-cost chip computer. With some tweaking, adjusting group membership and permissions on some devices, it runs well on Tiny Core Linux. OLR interfaces with Linux kernel by direct system calls. As of June 2017, OLR lacks a network layer. Project Oberon 2013. In 2013, Wert and Paul Reed completed a re-implementation of the original Oberon system for the Digiland Xilinx Spartan 3 FPGA starter board. The work includes a revision of Project Oberon, identified as Project Oberon New Edition 2013. In 2015, Reed collaborated with Viktor Yurkovsky to create Oberon Station, a Xilinx Spartan 3 based computer designed specifically to run Oberon. The system has since been ported to Xilinx Spartan 6 FPGA, Pepino development board by San Lima Electronics, and Xilinx Arctic 7 based Digiland Nexus A7 100 FPGA trainer board by CFB Software. Peter the Vakter implemented an emulator for it, which was also ported to Java and JavaScript by Michael Schill, running in modern browsers, and ported to free Pascal Ultibo by Marcus Grimm. Andreas Birkblauer maintains an experimental version and extensions of Project Oberon 2013 at GitHub. This is all I had on the part for Oberon, and it's good because I nearly ran out of time. In the next episode, now I clearly see that I can continue to the part 2 about Plan 9, and I don't know if all Plan 9 is gonna fit into one single episode, maybe even together with Inferno, and if not, then I have to separate those two parts into another two episodes. We will see. Normally, this thing works that I prepare the show notes, but I don't know how long it's gonna take for me to actually read my show notes or to talk, put it into words, and therefore sometimes it's just pure luck if a section I want to fit into an episode eventually fits or doesn't fit. There is really no, I cannot just look at text and decide and guess how long it's gonna take. I don't do these trial runs or demos to stopwatch myself to see how much I can fit into X amount of time. So that's why it's always a surprise for me as well to see how much I can compress into this half an hour format we are doing, or I am doing since pretty much the beginning, which is a good format. I would not go further unless I absolutely required or I really don't want to break an episode into two because there is not enough to be as a part 2. But yes, as you see, we are already on episode 76, slowly but steadily getting closer to 100 episodes, little by little. I still don't know much about the audience who listens to these shows. I have the statistics from the podcast portals like Spotify and the likes of it, but I know that many of you listens to it through the archives of like Anon Radio or Tilde Radio. So who knows how many people prefers that way, and those guys obviously will not show up on the general statistics. The website visits for the show notes website and the general website of the podcast are also revealing very little of who you guys are and where are you guys from, and who and how many of you listens. And as you are never very chatty or communicative towards me, which literally means no one sending me an email or any follow-up or just saying hi or hello. I'm listening to this show, and be as it may, I might even like it or I don't like it for a particular reason. Critic is always welcome, as long as it's in a decent format and in a way that everyone can learn something from it. So just I don't like it because it's normally not a piece of critique I could work with and implement some ways to as per that piece of information to make this show any better. But yeah, that was how much I was able to fit into this episode 76. It was solely on Oberon, and we will continue the next episode 77 next Saturday with Plan 9, and if we can fit everything of Plan 9, it's gonna be in one episode, and if not, then we will break it apart as a part 2 and include Inferno that as well. Thank you very much, and see you next Saturday.